Hi, I'm Adolph Oliver, and here in this video we're going to talk about getting the equation when we're only given 2 points. Let's overview what happens here. Okay, what will be given is 2 points here. I could take the first one to be x1, y1, and the second points to be x2, y2. Now, doesn't matter which one you make 1 and which one you make 2, so I always just make the guy on the left my first point number 1 and the one on the right my point number 2. Well, the first thing we have to do is figure out the slope ourselves, because whichever equation we're going to use, we need to have the slope. So remember that m equals, and rise over run, of course, and the rise is the difference in the y's, y2 minus y1 over x2 minus x1. Now, of course, what we do is we're going to make holes for all these guys with the minuses in between. Remember, we've worked with this formula before here. So y2 would be in this first hole. Here's the minus that's in the equation. y1 would be in the second hole here, downstairs. x2 in the first hole. Here's a minus in the equation. x1 in the second hole. Well, once we have the m, we can then use our m that we calculated along with one of the original points. I usually just grab the one I've got labeled x1, y1, but you could use the other one if you wanted. And of course, what we're going to do is put those in our point slope equation. Y minus y1 equals m times x minus x1. Okay, well, that's the general procedure we're going to have. Let's do some of these guys. So here we go. Okay, here's our first example here. And this one says, write the point slope form of the equation going through these points. Well, okay, when you're given 2 points like this, the first thing you have to do is calculate your own m. So I'm going to make this x1 and y1, and this x2 and y2. Labeling them like this increases your chances of getting things correct. Now remember, what's m equal? M equals y2 minus y1 over x2 minus x1. Okay, well, make your double set of holes, both top and bottom. Here's a hole for y2, and the minus sign that's in the equation, a hole for y1. Downstairs, a hole for x2, the minus sign that's in the equation, and a hole for x1. Okay, carefully put everybody in the right hole here. You have to be careful about this. It's really easy to goof this up. So the top left hole is y2. y2 is -1. You can see why I label them now. I can check easily. y1 is the top right hole. y1 is +1. Okay, going downstairs, x2 is the bottom left hole, that's 1. x1 is the bottom right hole, that's 5. Okay, well, we just have single signs in front of all the numbers, so we don't have to combine any signs. This is -1 minus another 1, so we end up with -2 upstairs. Downstairs, they have 1 minus 5. Well, this is +1 minus 5, so we end up with -4. Okay, well, finish this up. Remember the 2 minuses here combine to a plus, and of course we can reduce this to 1/2. So there it is. There's our m value. I'm going to use my first point up here. You could use the second one if you want, but I already have this one labeled x1 and y1. So now we go to the point slope form of our equation. Y minus y1 equals m times x minus x1. Okay, here we go. Make the holes again. Y minus, here's a hole for y1. Remember, drop the m in as you go by. It's safe to do that, and our m is 1/2 here. And then we have the regular x, but then minus and a whole for our x1 value. Okay, so as always, be careful here. Remember, this first whole is y1. y1 is 1. The second whole is x1, which is 5. Well, there's only single signs in front of these guys, so we can drop the parents, clean it up a little bit. Y minus 1 equals 1/2 times x minus 5. Now, since they wanted the answer in point-slope form, this is point-slope, and we can stop right there. Okay, here's one where they want the final answer in slope-intercept form. Okay, now, actually, we're given a gift here, so let's make use of it. You see this second guy right here? This is x equals 0. So that means this is a y-intercept. Okay, well, that being the case, we don't have to start with point slope. But we still, of course, have to find the m, so we don't get out of that. So let's do that first. M equals, remember the y's on top, y2 minus y1 over x2 minus x1. Okay, make your double set of holes again. So here we go. Here's a hole for y2 minus a hole for y1, all over a hole for x2 minus a hole for x1. Okay, well, I'm going to just label these guys x1, y1, x2, and y2 as usual. And let's see if we can get everybody in the right spot. Top left hole is y2, which is 2. Top right hole is y1, which is -1. Bottom left hole is x2 here, which is 0. Bottom right hole is x1. x1 happens to be 4. Okay, now we of course have to combine the two minus signs in front of this 1. That makes it plus. So upstairs I'm going to have 2 plus 1. That's 3. Downstairs 0 minus 4. Well, that's just -4. Okay, what's the slope then? Well, I can put the minus out in front here. Can't reduce to 3/4. So there is the slope. Now, notice, as we said, this guy right here is a y-intercept. We know that because the x is 0. So let's not toss that little gift away. And so that being the case, then that means 2 is the b value in the equation. Now remember, slope-intercept, y equals mx plus b. And the only reason we can use that here is one of our points happened to be a y-intercept, so we know what that is. So, okay, this makes this real easy then. Y equals, the m we got was -3/4 x, and then the b value was +2, so +2, and of course remember, they wanted slope-intercept form. We were able to use slope-intercept initially here because we did have a y-intercept. So always be looking to see if you've got a y-intercept. You can tell that if the x is 0. If not, then we would have had to use the point slope again. Okay, well, we're given 2 points again here. And this time they want the standard form. Remember, standard form means x and y to the left, plain number to the right. Notice we do not have a y-intercept here. To have a y-intercept, we'd have to have an ordered pair with x equal to 0. Y equals 0 doesn't make this a y-intercept. It actually happens to be an x-intercept, but we don't use those in our equations. So here we go. x1, y1, x2, y2. Okay, well, since we do not have, once again, remember, we'll point this out, this is not x equals 0, so that means it's not a y-intercept. So anytime we don't have a y-intercept, and the same is true for our second point here, then what we've got to do is use our point-slope form. But of course, to do that, we got to find what the slope is, so let's do that first. Here we go. M equals, again, the y's are upstairs. y2 minus y1 over x2 minus x1. Make your double set of holes with the minus in between for both the top and the bottom. Now, I have the guys labeled up here, and I've got what the formula says right next to it, so hopefully I can get everybody in the right spot. Top left value is y2. y2 equals 3. Top right value is y1. y1 equals 0. Bottom left value is x2. x2 equals negative 3. And the bottom right value is x1. x1 equals negative 5. Well, there is one of these guys that has more than one sign in front of the number. The 5 has two minuses, so we combine those to a plus. Okay, let's see what we end up with here. Upstairs, I've got 3 minus 0, which is just 3. Downstairs, I've got negative 3 plus 5. Well, positive wins by 2, so this is plus 2. So there's the m value right here. Okay, 3 halves, and I'm just going to use the point I have already labeled x1, y1. And of course, since we didn't have a y-intercept, that means we've got to use point slope. So y minus y1 equals m times x minus x1. Okay, as always, the first thing we do is make holes for the x1 and y1 values. So y minus, here's a hole for y1, equals m. Now we can drop that in as we go by here. So I'll put the 3 halves for m. And then in parens we have x minus, and here's a hole for x1. So as always, we're plugging in our x1 and y1 values, but remember now, this first hole right here is y1, so that's 0. The second hole over here is x1, and that's negative 5. Okay, let's do some cleanup. The 2 minuses in front of the 5 have to be changed to a plus. Y minus 0 is just y. So y equals 3 halves times x plus 5. Okay, now remember, of course, we wanted this in standard form. So the first thing I'm going to do is distribute in here. We've got y on the left, okay, equals 3 halves times x. Here we go, 3 halves times x. Now I've got to turn around here and also take 3 halves times the plus 5. Let me make a fraction out of this plus 5 by putting a 1 underneath it. So now you can easily line up a plus sign here. So the numerator 3 times 5 is 15. The denominator 2 times 1, which is 2. Okay, well, we want to move the x over to this side, but one of the things we also want is to get rid of the fractions. In the standard form, they don't like to have fractions. So you can see the LCD is going to equal 2 here. So what I'm going to do is multiply each and every term on both sides by 2. Here we go. One term on the left, I hit it. 2 terms on the right, I hit them both. Well, there's no denominator on the left to cancel anything against this 2, so it remains. But the other 2 guys, we cancel out the denominators. 2 goes into 2 once downstairs, and then the 2 up here once. Same thing on this guy. Okay, now let's put our leftovers together on this. Okay, I'm going to have 2 times y equals, well, this is going to be 3 times 1 times x, which is 3x. And then here we have plus 15 times 1, which is plus 15. Okay, well, only one thing left to do to get this in standard form. Jump the x over to the left side, because remember, standard form has both the x and y on the left. So this will come over as negative 3x. So I could write this as negative 3x plus 2y. Remember, it's officially plus 2y equals 15. Okay, there we are in standard form right there. Negative 3x plus 2y equals 15. Okay, and that follows what we were required to do in the original part of the problem up here, and that was, of course, to write it in standard form. But since we didn't have a y-intercept, we had to use the slope-intercept equation, the point slope, I should say. Here it is. And, of course, we had to calculate our OM as well. So we did rearrange it so that we had the x and y's on the left, plain number on the right. So there is standard form. Okay, now I want to point out to you that if you're ever given 2 points and they say they want you to graph it, the first thing you do is say thank you very much, because all you have to do is plot each of the points and draw the line. It's that simple. So let's remind you about this. Here we go. Here's the x and y axes. Okay. The first point is x equals 0 and y equals 3. 1, 2, 3. So there's my first point right there. There it is. The second point is x equals negative 2. 1, 2, and y equals negative 2. So there that point is. Okay, that's the second one. Well, I hate to tell you how easy this is. You got 2 points here. They're on the line. You know, it's a straight line. So just get your ruler out and draw the line through them. So making a graph given 2 points, there's a freebie for you if you ever have lucky enough to get something like that. Okay, well, what we've been able to do here then is get some good practice on how to use the point slope form of the equation. And of course, grafting here was real easy with just the 2 points.